Hello, Professor. My name is Joshua Rodriguez. My lab partner is Carlos Verdusca, and today I'll be presenting CECS346 Lab4. So as you can see here, I have two include statements. The first one being st.in, the hex file. Essentially, this is going to grant us some data types for the rising edge and the counts value. The second one is tm4c123gh6pm, the hex file, which is essentially going to act as a data sheet for our ports. In other words, it's gonna grant us many of the include statements for our lab, specifically for port F. As you can see here, we also have many different functions. The first three being disable interrupts, enable interrupts, and wait for interrupt, which essentially do as they're stated. The first one disables interrupts, the second one enables interrupts, and the third one waits for an interrupt to occur, and then it does something. Then the next five are functions that were provided in the lab. The first one being edge counter init, which essentially initializes the edge trigger interrupt for port PF0, which is whenever switch 2 is pressed. It acts as a rising edge interrupt, or triggers it. Then we have port F LED init, which initializes the LEDs for port F. These are the LEDs we're going to be using for the lab. Then we have 6-stick init, which initializes the 6-stick timer for a 0.1 second delay with the interrupt enabled. Then we have the GPIO port F handler and the 6-stick handler, which essentially means that these are the functions that will handle their respective interrupts. I also recall mentioning that stating that we have values known as rising edges and counts. The rising edge represents how many times the rising edge interrupt occurs. Essentially, this means that whenever we press switch 2, an interrupt occurs, and this value keeps count of how many times it does occur. When that does occur, essentially it increments whenever the switch is pressed. Then we have the counts value. Essentially, this takes count of how many times the 6-stick interrupt generates an interrupt. Essentially, these counts the amount of times that the LEDs switch from red to blue. It always increments by 1 whenever that happens. So as you can see here, in our main function, we have port F LED init, which initializes the LEDs for the lab, the edge counter init, which initializes the interrupt for the rising edge interrupt. Essentially, this is whenever switch 2 is pressed. And we have the 6-stick init. And as you can see here, we have this grant value. I believe it's 1,600,000 here. And the reason we have this is because since we're using a 16 megahertz clock, we are able to do the calculations, and we know that this value essentially equates to 0.1 seconds. So this is essentially gonna give us the delay for the lab. We also have the red LED set up here using this statement and the wait interrupt, which is essentially gonna wait for an interrupt to occur, and then it's gonna essentially do something. So if we were to go down here, we could see that we have most of our initialized statements. We have the port F LED init, which actually initializes port F LEDs, the 6-stick init, and the edge counter init. Essentially, these obviously have all the ports set up, so I could go over them, but it'll probably take too long. It's basically most of the same stuff we have. We set the system clock for port F, we have a delay, and we obviously unlock the ports, we disable the analog functions, we clear the bits, and we set up the inputs and outputs, and so on and so forth. The thing you should keep in mind is that we obviously have counts set to 0 for the 6-stick init and rising edges to 0. Essentially, we have these set to 0 because these are going to act as counters for whenever their respective interrupts occur. The two you should keep in mind are GPIO port F handler and 6-stick handler. The first one handles the interrupts for port F. Essentially, whenever the port F interrupt triggers, it essentially keeps count of that. So the port F interrupt triggers whenever we press switch 2. So I can see here we have 0x01, which essentially is port PF0, which is the flag 0 for port F. And whenever this is triggered, we obviously increment the rising edges, which is essentially how many times how much the rising edge interrupt occurs. We increment that value by 1, and essentially this takes count of how many times that interrupt has occurred, or when essentially that means it takes count of how many times switch 2 has been pressed. Finally, we have down here the CECS tick handler, which handles the CECS tick generate interrupts. So whenever the timer interrupt triggers, it toggles between the red and blue LEDs. So we have this data R set to toggle for 0x06, which essentially toggles PF2 and PF1. If we were to go back up here, we could see that the values for the red LED is 0x02, and the value for the blue LED is 0x04. Since we already know that the LED is set to red, we obviously want to toggle that one. And since we want to make sure that the blue LED lights up, we also have to toggle that one. So simply we combine the two and we get 0x06, which is the value we have down here. So essentially, since it starts off the red LED, when we toggle this value, the red LED switches off and the blue LED switches on. And this continues going forward. Then the blue LED switches off and the red LED switches on. And whenever this triggers, or whenever this interrupt triggers, the counts value increments by 1. So essentially this is going to act as a counter for the amount of times the timer interrupt occurs, essentially whenever 0.1 seconds happens or passes. So if we were to do a simulation, so we're going to go save, then build, and if we were to go to debugging, so we could see right here, we have a couple values. They're obviously all set to 0, and we have the port F hardware here, the simulation here. So if we were to run it, we could see down here, as you can see here, the red LED and blue LEDs are toggling between each other. And if you see down here, this value is incrementing. This is the counts value. So this is essentially counting up. It's always incrementing by 1 whenever the CECS tick interrupt occurs, essentially when the 0.1 seconds pass or when the LEDs toggle, as you can see here. And also, if we were to click switch 2 here, if you see down there, we have this value incrementing by 1. Essentially, whenever switch 2 is pressed, or when the rising edge interrupt occurs, it always increments that value by 1, and that value being the rising edges. So as you can see here, it's always incrementing by 1, signifying that there is indeed an interrupt occurring. So that essentially shows that this process is indeed working. So now, since we were to go for the debugging, let's see how we're able to do the lab project or the demo on the lab. So we would go to here, we would go to debug, and if we were to use here we go, and we were to build and then load it. Oh, sorry, I do not have it plugged in. So if we were to plug it in here, and if we were to load it, so I can see here, if we were to program it, you can see that the LED is constantly switching from red to blue, signifying that the demo is indeed working. And that's all I have for this presentation. Thank you once again, Professor, and I hope you're able to enjoy this.